Good morning. So today we're going to start talking about vectors, and a vector is a quantity involving both magnitude can't spell this morning magnitude is considered a length and direction. And direction is an angle. That it points towards. Okay, so an example of a vector quantity is velocity. Okay, we also have a scalar quantity, something that's called a scalar. But a scalar is a quantity involving just magnitude. Okay, and then this one, example of this one would be like a speed. Velocity, you know the length that you're going to travel, and you know a direction. With scalar is a quantity, speed, you just know the speed. You just know the length that they're going to be going. All right, so let's look at these. Are these representing two equal vectors? I'm going to try to draw these very good. So would U and V, or U and W, I'm sorry, U and W be equal vectors? Okay, so an equal vector means that they would have to have the same length and going in the same direction. So we're just going to assume that these two, yes, I meant to draw these the same. So yes, yes, U is going to be equal to W. So the length is going to be the same and they're going in the same direction. Okay, so what about these? Are these going to be two equal vectors? Would these be considered two equal vectors here? Okay, the answer here would be no, because the direction is going in opposite direction. So the magnitude is the same, but the direction is different. Okay. All right, so what about this one? All right, so what about these two vectors? So vector U, vector W here, the answer here would be no, they're not equal because the magnitude is different. But direction is the same. So a vector from the origin. So if we were to look at a vector starting out at 0, 0, so a vector is basically an array in standard position. Okay, so vector I is the unit vector whose direction is along the positive x-axis. Okay, so I is going to be your x-axis and j is going to be your y-axis. Okay, so we're just going to give you a bunch of definitions and then we'll work some problems. So vector v from 0, 0 to some point AB. So here's some point up here, AB. Okay, is represented, this is how it's represented, is represented as vector V is going to be equal to AI plus BJ. And so this is linear combination. Okay, so this is in linear form here. Okay, so A represents the horizontal value, right? And B is going to represent the vertical. Okay, so A is the horizontal. And B is the vertical. So to find the magnitude, basically what are we going to do to find the magnitude? And the magnitude is kind of a crazy. It's going to be basically double absolute value, but that's considered the magnitude of V. So the magnitude of V here is just going to be the Pythagorean theorem. So the magnitude is just going to be the Pythagorean theorem. So square root of a squared plus b squared, and that will be your magnitude. Okay, so let's do an example of this real quick. So sketch the vector v equals -3i plus 4j. So, and find its magnitude. So I want to sketch this one in my standard form here. So that means I'm going to start out at my terminal side 0, 0. So this -3, so this a, so a here is going to be equal to a -3, and b is going to be equal to a 4. So that means I'm going to go 1, 2, 3, and b is going to be 1, 2, 3, 4. So this is going to be the vector v here. Okay, so the magnitude of v is just going to be a squared, so -3 squared plus a 4 squared. So that's 9 plus a 16, which is a 25, and square root of 25 is just going to be a 5. So the magnitude of v here is just going to be 5 units. Okay, not too bad. All right, so what about if it's not in standard form? So if it's just in rectangular coordinates? Okay, so let's call vector v with an initial point P1, so that's going to be some x value and another y value. Okay, so vector v is going to have an initial point at P1, so we're going to be somewhere inside of here. Let's just call this P1, and let's just call this one P2. Okay, so we're looking at vectors that, a vector here that's not in standard form, so how do you determine it? Okay, and then, and a terminal point at P2, so that means that you've got an x2 and a y2. Okay, so very similar to if it was starting out at the origin, so your origin here would be P1, and your terminal point would be P2 here. Okay, so it's basically the same thing. Okay, so this is going to, how do I find the position vector? So so it's going to be equal to the position vector. So we'll say x2 minus x1, so you're just finding the difference between your x values, and then your y2 minus y1, finding the difference between your y values. Okay. All right, so let's do this question here. So we're going to let V be the vector from point P1 to P2, write V in terms of I and J components. All right, so this will be considered my x1, this will be my y1, this will be my x2, and this will be my y2. So my vector V is going to be x2, so -6 minus a 2 with your I component, and then 6 minus a -5, which will be your J component. So this will be a -8I plus an 11J. Okay. All right, so do that B1 for me. Alright, so here's your x1, here's your y1, here's your x2, and then here's your y2. So your vector is going to be 7 minus a -1 plus -5 minus a 6. Sorry, that's a J. So this will be 8I minus an 11J. So now this is going to be the vector in standard form. Okay. Alrighty. Alright, so let's go back to our definitions here. So we can add and subtract vectors together. So vector addition and subtraction. Okay, so let's call vector V is going to be your A, let's call it A sub 1, I plus B sub 1, J, and let's call U A sub 2I, B sub 2, J. Okay, so if I wanted to add these two vectors together, so I'm going to add the components together. So if I wanted to add vector V plus vector U together, I'm just going to add my A1 plus my A2, and I'm going to add my B1 plus my B2. And it matters. So if you said V plus U, you would say A1 plus A2, b1 plus b2. But if you were to say u plus v, you would say a2 plus ai, or a1, I'm sorry, and b2 plus b1. Okay, so the order of that matters. Whoops. So here, u plus v. So this would have been a2 plus a1. And it really doesn't matter with addition, but it will matter when you subtract them. Okay. So just the order of it matters. Alright, so then if I wanted to subtract them together, so I would say v minus a u. So same thing's going to happen. I'm going to say a1 minus an a2. And then b1 minus a b2. So that's vector addition and subtraction. And also scalar multiplication. So that means if I want to multiply a value times my vector. Okay, so scalar multiplication. So if I'm multiplying a scalar times my vector. So let k be a scalar. And v be your vector. So if I wanted to multiply k times v, okay, then I would multiply k times the a component of my vector, and I would multiply k times the b component of my vector. So that's scalar multiplication. Okay, so addition, basically you're just adding your components together. Multiplication, same thing, you're just multiplying the number times each part of your component. Alright, so let's look at an example here. So we are going to let u be equal to 2i minus a 5j. V, vector v, is going to be equal to negative 3i plus 7j. And vector w is going to be, that is a negative I minus a 6j. Okay, so I want to add v plus w together. Okay, so if I'm going to add these, I'm going to add the two components together here. Okay, so v plus w is going to be a negative 3 plus a negative 1, I, and then 7 plus a negative 6, j. So this will be a negative 4i plus a j. And that becomes your new vector, v plus w. Okay. B here, that says 6 times v here. Down here for C, this is 3u plus 4v. And then here I want to find the magnitude of u minus a w. So I want you to try to do those for me real quick. Alright, so 6v here would be 6 times a negative 3i plus 6 times a 7j. So that would be a negative 18i plus a 42j. Okay. Alright, so here we want to do 3u plus 4v, and then so I'm going to add these two together. But the first thing I need to do is do 3 times u and 4 times v. Okay, so 3 times u, 4 times v, and then add them together. Okay, so 3u is going to be 3 times 2i minus 3 times 5j. So this will be a 6i minus a 15j. Sorry, something is messing up. I apologize. So 4v, so I'm going to say 4 times a negative 3i plus 4 times a 7j. So that'll be a negative 12i plus 28j. Okay, and now I want to add those two together. So 3u plus 4v. So I'm going to add these components together. So I'm going to say 6. Okay, so 6 plus a negative 12, so it's going to be a negative 6, right, I. And then negative 15 plus a 28, so negative 15 plus a 28 is a what, 13? J. Alright, so then here we want to find the magnitude of u minus w, but the first thing I need to do is find u minus w. So, what is u minus w? So here is my u and here is my w. So I'm going to say 2 minus a negative 1. So it turns into a positive. And then I'm going to have negative 5 minus a negative 6. So this will be a 3i plus a j is going to be u minus a w. Okay, so then to find the magnitude here, so the magnitude of u minus w is just going to be this component squared plus this component squared and the square root of it. So that's 9 plus a 1, which is a 10. So this is going to be a square root of a 10. It's going to be the magnitude. Okay. All right. Also, we have something finding a different vector. Okay, so finding the unit vector. That's in the same direction. So another unit vector in the same direction. So for any vector or non-zero vector v, the vector v divided by the magnitude of v is the unit vector in the same direction. Okay, so it has the same direction. Alright, so let's look here. So find a unit vector that has the same direction as vector v here. So v is a negative 5j. It's a negative 5j there. So the magnitude of v is going to be 0 squared plus a negative 5 squared. So that's going to be 25, so the magnitude is just going to be a 5. So the same unit vector that's in the same direction is just going to be your vector v divided by the magnitude of v. So it's going to be a negative 5j divided by the magnitude, which is just a 5. So this is just going to be a negative j here. So this is the same, this is a unit vector that has the same direction as my original vector. Okay, so y'all do v for me. So v, the vector v is going to be 4i minus 2j. Okay, so I need to find the magnitude of v. So that's going to be 4 squared plus a negative 2 squared. So that's what, 8 plus a 4, which 8. 16 plus a 4, which is going to be a 20. So that's going to be what, 2 square roots of 5. All right, so my magnitude is going to be 2 square roots of 5. So I'm going to take my v and I'm going to divide it by the magnitude of v. So I'm going to take 4i and divide it by 2 square roots of 5. And I'm going to take 2j and divide it by 2 square roots of 5. So this is going to be 2 over square root of 5i minus 1 square roots of 5j. But remember, we like to rationalize the denominator. So this will be, what, 2 square roots of 5 over 5i minus square root of a 5 over a 5. Okay. So here is the unit vector. Good. All right, and last but not least, if we wanted to write the vectors in terms of I and j, okay, if we're given a magnitude and we're given an angle here, so writing a vector in terms of magnitude and direction. So if we're given some angle, so if we're given a magnitude and we're given a theta, an angle, a direction, okay? So if we know the magnitude and theta, so remember, okay, so your x value is going to be cosine, right? And then your y value would be sine. So how you would write your vector in standard form would be the magnitude times cosine of theta, and the magnitude times sine of theta. That's a j. Because that would be your y direction and this would be your x direction. Okay? Alright, so let's go back to this one here. So we have a magnitude of v is equal to an 8, and my angle is 45 degrees here. So how can I write this vector in terms of a position here? So it's going to be 8 times cosine of 45 degrees, I, plus 8 times sine of 45 degrees, j. So cosine of 45 degrees is square root of 2 over a 2. And sine of 45 is square root of 2 over a 2. So this is going to be 4 square roots of 2i and 4 square roots of 2j. So there is your vector v. Alright, so that's vectors. And that is basically all that we are going to do this week, vectors. So on the quiz on Friday, it will be vectors and polar graphs. So if you have any questions about anything, let me know. Y'all have a good day.